Hello everyone, today I will show you how to design strut and tie method compared with moment method. This is a plan layout of ground beam and pie cap. It is a pie cap, it is ground beam, and it is a ball pie diameter 80 centimeter, and it is the column above. And I will pose you some question, and why we use pie cap, what is the constraint will be used for the column, pie cap and ground beam, and what the dimension of pie cap and ground beam. And it is the schematic of our structure, ball pie, ground beam and the column above. And this is the distance between the applied load to the face of the concrete ball pie. And we have to determine the dimension of pie cap and dimension of ground beam. We have some data from superstructure, which is the ultimate load or vector load. It is the plane view of the pie cap, and the minimum is 20 from the face of the ball pie if 150 millimeter recommended by the code. So you should extend it or the side of the pie cap, but in the side we extend to support the concrete column. Extend to 500 and extend more to 150 to support the column above. And now what is the meter between the moment at the surface of column and the moment at the center of column? It is the concrete ball pie. So when we apply the ultimate load at this point, and if we multiply the ultimate load with the level arm at the surface and at the level arm at the center of the concrete ball pie, we will get the different result. So the difference between these two results is equal to 660 kN or is equal to 44.44%. So the 44.44% will be make the different reinforcement also 44.44% between those two moments. So which moment we should be used for calculation? This one or this one? Why we use this one or why we use this one? So let's compare with the strut and tie methods. And now the first step we have to calculate the rebar according to the moment method or according to the beam methods. At the height of the section and the width of the section, it is the width of the pie cap and this is the width of the beam. You can design width for of the pie cap and or the width of the beam and compare the results. And the cover to reinforcement 50 cm, bending moment, ultimate bending moment, cylinder strength for the zero code 2 and should be strength for the British standard code, and the reinforcement strength is equal to 200 megapascal. We try to compile with the zero code 2 requirement. The minimum rebar strength is equal to 400 megapascals, but actually in my country the reinforcement strength is equal to 390 megapascal. but now we use the recommendation, the minimum reinforcement strength for the 0.2. Assume the rebar diameter 25 meter at the tension zone, and this is the quick design or briefly design. The required reinforcement is called the ultimate apply moment divided by design strength of rebar multiplied with the level arm. So the maximum level arm in the consideration use 0.25 the maximum level arm for single reinforcement, and the D is equal to the height minus cover to centroid rebar. The centroid rebar we include the cover rebar 50 millimeter, and from the cover from that to the centroid more 50, so we say 100 millimeter. So the effective depth is equal to 800 millimeter. So the maximum is 0.95 D, but now we use only the 0.22 D for the quick calculation. So it is the result or rebar, and the result is the same for the UK and the General Code. For this slide, it is for detailed calculation based on the 0.2 height and B 1.1 meter, and here B is 0.4 meter, and we have the different result of the required reinforcement here and the provided reinforcement here. For the BA81 train British Standard Code, we compare with the different width of the element. In this one we use the width of the pie cap, indicate if we use the width of the ground beam. So we got the design reinforcement or required reinforcement score here, and provided we see the two code provided reinforcement is the same. It is some bright result. The design code 0.2 BS8110 British Standard Code, but indicate we compare only the provided rebar, we not compare the required rebar. Now let's check with the Strut and Tie method. The Strut and Tie method, we have to calculate the angle of strut. Here the angle of strut. Here apply load, in compression, strut in compression, and tie in tension. The angle of strut equal to 45 degrees. After you got the angle of strut, you can calculate the force per strut and the force in tie. Now we want to design the rebar at the tie zone. So we take the value 1600 kN to calculate the tension rebar at the top of the pie cap. The required rebar mass greater than or equal to 4 per tie divided the design strength of the rebar. So the result is 3,478.26 square millimeter. We use 7dB25. For the shear, it's not a sweet call. We call the AV less than 1.5D. So the punching section is in the bracket in the case. So the punching here. It says we check at node 1. You remember the node 1? Node 1 here, node 1. The sigma of the applied stress or the applied load is equal to the total load divide the cross-sectional area of the column at the base, and it is the applied stress is equal to 13.33 megapascal. In the case of the node, it is usually compression CCC. We got the result 15 megapascal, but in this node not resist surely compression stress but also compression and tension in the node, so we reduce 15% by multiply 0.85 with the 15 megapascal is equal to 12.75 megapascal. Check here, it is compression, but it is tension. So we call this node 1 CCT, compression tension. Okay, CCT, compression tension. So let's compare with the applied stress. The applied stress greater than resisting stress. So we should increase the strength of the pie cap to 32 megapascal or 35 megapascal, and after that you should calculate the resisting stress again, and to make sure that value must be greater than the applied stress here. But you can observe that the formula is applied only for the concrete strength, not include yet the reinforcement strength. Actually, we provide more rebar in the concrete, so the resisting strength will be increased. Okay. Now let's compare the summary result between the method 1. Method 1 is the moment method, but we take at the face of also both high only. Compare with the Strut method, we got the similar result. Okay, we got the similar result. In actually we use 8 dB25 at the tension zone or the top of the pie cap. Here section 1 in the pie cap we use 8 dB25, and for other side of the ground beam we extend only 4 dB25 for whole structure of the top and bottom. And for the moment at the center of the ball pie is over 44.44% of the summary result. Okay, to conclude that in the case that we take the moment at the face of the ball pie, the result is the similar with the Strut and Tie method. And why we take only the face of the ball pie? Because the overlap zone between the concrete ball pie and the concrete pie cap is called rigid zone. In this zone not resist the shear deformation, so we can take the moment, critical moment, only at the face of the zone. Is we manually calculating according to the hand calculation or use the ODM. We use at the center of the ball pie we got the higher result than at the first or double pie. So the difference is 44.44%. To minimize and optimize the rebar at the top, you should compare this method with the Strut and Tie method. I think it's a good idea for Strut and Tie method can apply for this structure. Okay, thanks for your watching.